Professor M, how are you?
I'm pretty good. How about you?
I'm great. Welcome back for another Mad Science Monday. Today we're doing bubble engineering. Okay.
That's so much fun.
And you know that we post our materials the day before Monday, which would be Sunday. And so you can be ready to do the experiment with us, or you can just do it as whenever you have the time. So let's talk about what we need today. Okay. You need water. On the ingredients list, I think I said 6 cups of water. We're going to half everything because we have a container that will not hold 6 cups of water. So we're going to cut it in half and do 3 cups of water. So there's our 3 cups of water. And your container needs to have a lid when you're finished because you want to close it up so that your water doesn't evaporate. We need a ½ cup of Dawn dish detergent is what we're using. Dawn works best to make this bubble solution. Ooh. Isn't that pretty? Now we're going to try to kind of swirl it and mix it up when we're finished adding our ingredients, but we don't want to make it real bubbly, not yet. Okay, we need 1 tablespoon of glycerin, and you can get glycerin. I almost think I got this at the grocery store, but you can get it at the drugstore. And that's kind of a secret ingredient to helping make the bubbles. And then, like many of our experiments, you got to have some patience. They say to let this solution sit overnight with a lid on. You just want to either take a spoon and stir it gently or just swirl it, but cover it because otherwise some of your liquid will evaporate. So let's talk about a couple words that are going to be important in this experiment. The first one is the one I just mentioned. It is evaporate. You may know that word. It's when liquid dries up and turns into a vapor or gas. It's what happens all the time. It's part of our water cycle. All right, so that's the word evaporate. I'm going to mention the word molecule to you. Now, everything on our earth is made of atoms and molecules. Molecules are made up of atoms. We can't see them. But every material on earth, and including things we can't see, like air, are made of molecules. They're the building blocks of everything. All right? And the really important word today is surface tension. Surface tension. What happens with liquid is the molecules are very attracted to each other, so they come together, causing the top or surface of the water to form together in a tight bond. And if you ever wondered about water when it drips, think about the shape. What shape does water come out in?
I think water comes out in droplets. Oh, water comes out in droplets.
It comes out kind of like in a round shape. It doesn't come out in a square. Doesn't look like a triangle. It's because of the surface tension that's holding that water together. And so that is part of our experiment today that we'll be talking about. Okay, we're going to now go into our experiment. And so one other thing I didn't mention, you'll want to have pipe cleaners so you can make your own bubble wand.
You want some straws.
You need some straws, and you need a pointed object. I brought 2 pairs of scissors because we're going to do part 2 of our experiment will be with a pointed object. You could use 2 pencils with points on them. Okay. All right.
This is our solution that's been sitting for a couple days, I believe.
Yes.
And it's ready for this experiment.
Right. So we let this one sit, and it's ready. And notice it has a lid. I'm not going to shake it up, but you can just twirl it and make sure that that glycerin gets in there. Okay. We have 2 parts to our experiment. The first one, we want you to make your own bubble wand. Now, we have a couple bubble wands here. You can see the shapes?
Yeah. We have a square
and
a star.
Okay, so think about if we dip our square into the solution, what shape will the bubble be? What do you think it would be?
I think it will come out square. Or would it come out?
I kind of was thinking the same thing. That would make sense to me. Or it might come out looking like a star. Okay, but we're going to make our own bubble wand. So, Miss Professor M, would you like to make a bubble wand?
I would love to.
I don't know what shape it's going to come out like. It's kind of, whatever it comes out is fine. We're just going to try to use it and see if we can blow a bubble with it. The other thing you'll want is maybe, I have a bubble pan here, but I would have brought a pie pan if I didn't have these. So I'm going to pour some of our solution into here so we're ready to try and blow a bubble.
You can also use a shallow plate.
Yes, so let me pour some in here so we're ready to blow our bubbles. And I might even try blowing one with our ready-made wands. I'm going to fill this up really, really good.
So I chose to do a heart and with one of the pipe cleaners, and with the second one I am making a handle.
Okay, while you're finished, oh, you're almost finished with it.
Yeah.
I'm going to mop up a little bit of the bubble solution that I spilled. Always good to have something underneath your experiment, or you can work over the sink. I'm kind of messy, so I'll just mop that up so we don't get it all over us. But it is just dish detergent, so it doesn't really matter.
Helps you clean the table as you go. So see guys, this is my shape. I chose to do a heart with a little handle.
You did an excellent bubble wand, much better than me. Okay, so let's look at Professor M's shape. What do you think? Is it going to come out looking like a heart? And if you're ready, we're going to try it out. Are you ready?
I am ready.
Okay, go
so
ahead.
I'm going to take my wand and I'm going to dip it in the solution.
Make sure it gets really wet and that you can see the solution. Now, hold here. I'll move this over so you can kind of, because it is dripping a little bit. And let's see if we can blow a bubble with it.
Okay.
It's going to have to take off our mask for this. What? Do it again, and can you hold it up so that they can see? Think about the shape that it is. What shape is this bubble coming out when she blows the heart?
Whoa.
Did it come out like a heart?
Mm-mm.
It did not. Let's look one more time.
Let's try that again. Soak it in.
This would really be a good thing to do even outside.
When it's not so cold.
Oh, that is a great bubble. Oh my gosh. Can I try it?
Yeah.
All right. No, I'm going to try it. I'm going to try it with this shape. So the heart came out like a round circle. Let's see. I got bubble solution in there. I'm just going to put my paper towel under it. Oh, that wasn't very good. Let's try it again. It's dripping a little bit. Could you see it?
Yeah, it was a circle.
What?
Yeah, try it again. See if it works. Or
All
maybe
right.
you want to try the square?
Why don't you try the square? I'll try the star again while you're getting that one ready. Okay. Let's see. A circle. A circle. Boy, that one blew a great long bubble, but it came out round. Okay. So the reason it's coming out as a circle, let me put my mask back on, so we want to keep ourselves safe, is surface tension. The molecules gather together in the liquid, and the simplest shape is a circle. It takes less space, and so that rim around the circle is pretty strong, and it holds the rest of the liquid bubble together and forms a circle no matter which of the shapes that we used. We're going to try one more thing, a second experiment, okay? So you make your bubble wand, you try it out and see if you can get a different shape for the bubbles, okay? But we could not. The star, the square, the heart all came out in a circle, which is how surface tension works. So you need your straw and you need your bubble solution, and Professor M is going to blow bubbles in the dish, and you also have to have two pointed objects. Now what we're going to do, I'm gonna dip one of my objects, my scissors, into bubble solution and get it really good and wet, okay?
While Professor L is doing that, I will go ahead and blow some bubbles in our bubble pan.
Okay, good luck. Now she's blowing a lot of bubbles. I hope you can see them. Maybe we can get some big ones, I don't know. So we got a dish full of bubbles here, and we have a very wet pair of scissors. If we stick the scissors into that bubble, what is going to happen? Are you ready to try it?
I am ready. We'll see what happens. Put down below what you'll believe is going to happen. Oop.
Oh gosh. Can you see this? Let's try it again, because it's hard to see the little bubbles.
Yeah.
We're going to blow it up again and try to get a really big bubble. It's not as easy as it sounds. We're getting lots of little bubbles. I see some big ones. Okay, this one is very wet, and she's going to dip it into the bubble.
Okay, here we go.
I think it should pop. It doesn't pop.
What?
But, okay, take that out. Now we have a pair of dry scissors. Let's dip it into that same bubble, because it's still there. It popped it. See if it'll pop the others. Why? Why do you think the scissors dipped in liquid in the bubble solution didn't pop, but the scissors that were not wet did pop the bubbles? Okay, do you know why?
I do not remember.
Okay, these scissors had bubble solution on them, so the minute they go into the bubble, that liquid just expands into the other liquid of the bubble, doesn't pop. This guy that did not have any bubble solution on it just popped, popped, popped those bubbles. It has to do with surface tension. And that is the end of our experiment, bubble engineering today. So make your bubble solution. It'll last a long time as long as you keep the lid on it. Remember, you gotta wait a day. It gets stronger, I think, as it sits. And then make you a wand. If you don't have pipe cleaners, what could you use?
I think,
You could use wire if your dad had some wire.
yeah, or the twist ties that we use on bread that sometimes we have laying around. We
You
can
can
also
make
try
little
to-
tiny ones, yeah. So, you know, we've just used what we had. I had mason jars. If you have a bigger bowl, you can make more solution, go outside and blow bubbles till it runs out, and it'll last a very long time. Okay, well, that's the end of today's experiment. Thank you, Professor M, for helping.
No problem.
So awesome to have you here, and we'll see you again, okay, for Mad Science Monday at 4:30. Remember, we post the ingredients the day before. We also post them underneath of our experiment when we put it up, so you can do it whenever you have time. Bye.
Bye, guys.
Have a great day.